Alright guys, let's talk about the beauty of 9 today in this video. So precisely what we're going to cover today in this particular session is going to be table, okay, how 9's table is very beautiful. Casting out 9's, very important property of 9. The remainders of 9 very crucial for people who are taking CAT and MAT and SNAP and ZAT for that matter. In fact even CT, and a few CAT questions and other exams questions that we'll solve. Okay, so let's talk about the table of 9. You might have been informed in school, like, if you write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 in this manner and start from 0, 1, 2, 3, 4, 5, 6, 7 and 8, you get the table of 9, and you can have a 0, 9 here too. Alright, this is one of the properties, not a big deal at all. I mean, it's very simple. The obvious thing here is the addition of all the multiples is 9, and this is very important property. So you want to check whether a number is a multiple of 9. For example, 273, it is not a multiple of 9 precisely because 273 adds to 12, which is not a multiple of 9. And that's how this functions. So let's take it forward. So what else can be in 9? So let's talk about casting out nuts. But before we go there, let's understand one thing. Let's say you want to find out the sum of digits of 41. So you just say it's 4 plus 1, 5. Let's say you have a question, find the sum of digits of 273. So you'll say it's 12, 3. Let's say you have a question which says find the sum of digits of 9 and 1, 9. So it's going to be 28. 28 is basically 10. 10 means 1. Okay. So let's say you have a question, find the sum of digits of something like this. Okay, it keeps going on and on and on. Alright, so something like this, or maybe you can add a little more here. Okay, so you'll be a fool if you probably add everything, like literally add everything and get the value, because it'll take a lot of time, and we don't have time in these kind of competitive exams. So what you can do is, if you notice carefully, 9 actually is such a beautiful number that actually doesn't take part in the addition process at all. So 9 when added actually is not added at all. In fact, it removes itself. Okay, so for example, what do I mean by this? 4 plus 1 is 5. That's fine, we don't have a 9 here. If you notice here, I have 3 9s. I can actually cancel 9s and get the answer as the final answer 1. Okay, now if you look at 273, so I can cancel 2 and 7, which is a 9, and I get 3. So let's say I have another example here. If I have 9, 4, 5, 3, 6 and 2, so you can use cancel 9, cancel 4 and 5, they give you a 9, cancel 3 and 6 and they give you a 9, the answer is 2. Okay, the beauty of this is this number is not just the sum of digits of this number, it is also the remainder when I divide this number by 9. So for example, if we have a question something like 1 2 3 4 5 6 7 8 9, a typical question again, okay, and some continuations here. I'll just finish the continuation as is 3. Okay, so this is divided by 9 and find the remainder. So all you gotta do is cancel 9. So if you have 9 is cancelled, 8 and 1 is cancelled, 2 and 7 cancels, 6 and 3 cancels, 4 and 5 cancels, so the answer is 3. So when I divide this number by 9, the remainder is going to be 3. Alright, so coming back to this question, what will be the sum of digits of this kind of a number? All you have to do is cancel 9. So if you notice, I have 639 549. Okay, you can cancel something like here 9 and 9. You can cancel the numbers that are 9 by itself. Okay, 8 and 1, 7 and 2, 6 and 3, 5 and 4. So I'm left with a 7 here. Okay, I am left with 2, which can be cancelled, and 1. So that's precisely how this functions. So the sum of digits would be 1 in this case. Alright, so whenever you want to find the remainder when divided by 9, always keep in mind you just have to find one thing, sum of digits. Okay, and it's vice versa. Okay, sum of digits is also the remainder, or remainder is sum of digits precisely. Okay, so let's take a simple example. Let's say you have something like this, 4 raised to 100 divided by 9. What is the remainder? Okay, now you might know the remainder theorem, you might know formats, rulers, whatever, it doesn't really matter. But when it's 9, it's a beautiful thing, because you can say, you just have to do one thing, you have to find a power of 4. So let's say I have 4 cubed for that matter. I can say 4 cubed raised to 33 into 4 divided by 9. So 4 power 3 is 64. 64 raised to 33 into 4 divided by 9. And now I just have to find sum of digits. 64 and 33 is basically 64 into 64 into 64 33 times. Okay, so each of them gives you a sum as 1, and so on. So I can say it is 1 raised to 33, which is 1 into 4 by 9, which means the remainder is 4. And that's how simple it gets when it comes to dividing anything by 9. Alright, so let's take another example. Let's say you have something like 221 into 643, just giving you random numbers, into 7 to 8 divided by 9. So all I gotta do is find the individual remainders here. I get 5 here, sum of digits. Okay, you don't have to practically divide by 9, find a multiple around it. Out here I can cancel this, I get 4. Out here I can cancel the 8. So now I can multiply 5, 4 and 8. 5, 4 is gonna give me 20, which is 2. Keep in mind, you can keep doing the sum of digits again and again. So instead of using a 20, you can use 2. So 2 and 8, 16. 16 by 9 is 7. Precisely, that's the answer. I mean, it gets this easy. Let's have a look at a CAT question. I mean, a couple of CAT questions that are based on this. CAT and ZAT precisely. Any exam that is above CAT precisely. Let's talk. So let's see. Let's say we have a question, something like this: 1, 2, 3, 4. A famous question. You might have seen this in a lot of mocks now. 8, 9, 10, 11, 12, 13, etc. till 1003. What will, if this is n? What is the remainder when n is divided by 9? So precisely, we have numbers written in horizontal fashion. So I can categorize this. Okay, you must know these kind of things beforehand. I'm explaining this to you in detail right now. 10, 11, 12, etc. till 99, and then I have 100 till 999, and then I have 4-digit numbers: 1000, 1001, 1002, and 1003. Let's analyze these numbers. So let's look at the first set. If you notice, I have 9, I have 8, 1, 2, 7, 6, 3, 4, 5. So first row gets cancelled completely. Looking at the second row, you can look at the second row in a different manner altogether. Look at this in this fashion: 14, 15, 16, 17, 18, 19. Okay, just look at the units place of these. The units place of these is as good as these numbers. So 0 to 9, which means units place will be cancelled like the way we cancelled the first 9 numbers. So we're left with only the tens places. So from 10 to 19, we're left with 10 ones. Similarly, from 20 to 29, we'll be left with 10 twos. 30 to 39, 10 threes, and so on till 90 to 99. Because 90 to 99, you'll be left with 9 nines. 10 nines, sorry. Got the point? So units place will be cancelled as per this, and the tens place we will have 10 ones here, 10 twos here, 10 threes here till 10 nines here. Now notice the 10 ones here can cancel 10 eights here, 10 eights. Alright, 10 twos will cancel the 10 sevens, etc. Basically speaking, the entire row goes away. Third row, the same thing. You look at the units place of each and carry forward the same thing, and then you'll be left with, in this case, you'll have 100 ones, 100 twos, 100 threes, and so on. They all will be cancelled because 100 ones will be taken care of by 100 eights, 100 twos will be taken care of by 100 sevens, etc. Anyway, you just left with these 4. Okay, now look at the number. Actually, the problem has now shortened to just 4 numbers. So we'll look at the digits now. 1 is there, 1 is there, 1 is there, 3, 3 and 1, 4, 4 and 2, 6. 6 and 3 cancels because of 9. Okay, and you're left with 1. So the answer to this is 1. So let's summarize this problem. So whenever you have something like this, n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till, let's say, any number you want to, 1004 for that matter. Okay, you must know that if I have all 1-digit numbers, they'll be off. Okay, they'll be casted out. All the 2-digit numbers will be casted, and all 3-digit numbers again would be casted out. Okay, so if you have the set of all 3-digit numbers, all 2-digit numbers, and all 1-digit number, they all will be casted out. So you'll be left with only the 4-digit numbers, which is in this case 1000, 1001, 1002, 1003 till 1004, and you can do that calculation easily. Alright, that's the beauty of 9 when it comes to CAT questions. Okay, stay tuned for more things tomorrow. Thank you very much. All the best preparing.